do so?
The EDS system shows superior stability at high speeds, but the infrastructure cost is substantially higher.
Exactly.
Electrodynamic suspension engineering creates systems using repulsive forces between onboard superconducting magnets and guide.
Composite material fabrication lays carbon fiber and epoxy, creating ultra-lightweight structural panels.
Aluminum extrusion produces structural profiles forming vehicle frame skeleton. Specialized alloys provide excellent
The reinforced glazing is now being secured. This design ensures structural integrity even under extreme aerodynamic pressure.
Electromagnet winding wraps copper conductors around iron cores, creating controlled magnetic fields. Conventional electromagnet.
Superconducting coil manufacturing produces cryomagnetic sphere.
Cryogenic cooling system installation integrates liquid helium or nitrogen cooling, maintaining super temperatures.
Levitation control system integration installs sensors and computers, maintaining precise suspension gap. Millisecond response times adjust magnetic force.
239.316.
Mechanical friction devices contacting guideway rails. Fail-safe braking provides stopping capability during power failures or system malfunctions.
Provides back-hour sub-electregation, provides back-hour system.
pressurization system integration maintains
The connection is flawless, even at this speed.
Yes, I'm looking at the updated reports now. We are definitely on track for the merger next quarter.
Single file, feet first. Keep moving down the slide.
We've got you at the bottom, just keep coming.
Slate 239.31. Fire detection and suppression installation positions sensors and extinguishers throughout the vehicle.
Track-to-vehicle communication installation provides continuous data link with guideway systems.
Exterior shell assembly joins aerodynamic panels, creating smooth, continuous surface. Seamless exterior minimizes
Paint application applies specialized coatings resisting high-speed abrasion and environmental exposure. Durable finish.
Vibration damping installation applies materials absorbing structural oscillations. Sophisticated damping maintains passenger comfort.
Electromagnetic shielding protects passengers and electronics from magnetic fields. Carefully designed.
And alley, which tempers ability to operates the vehicle at increasing speeds, evaluates ride quality.
239.48. High-speed testing accelerates vehicle toward maximum design velocity.
249.49. Braking performance testing measures stopping distances from maximum speed. Safe.
Emergency scenario testing validates fail-safe response to system malfunctions. Comprehensive.
239.51. Noise measurement testing quantifies interior and exterior sound levels. Electromagnetic compatibility testing ensures systems don't interfere with each other or external equipment.
Passenger comfort evaluation measures acceleration forces and vibration throughout the speed range. Ride quality testing validates passenger visits. Quality inspection examines every system and component, verifying build quality. Rigorous inspection ensures delivery.
The stability control metrics are excellent. The system reports the acceptance tests are complete and all parameters are nominal.
The magnetic fields are managed here. It's fundamentally different from friction-based braking.
And we adjust the parameters using...
Correct.
The magnetic flux requires precise calibration, especially with the new suspension array.
239.60. Spare parts provision establish inventory supporting specialized maintenance.
Okay, let's initiate the transfer slowly. Keep the pressure steady.
Pressure holding at 20 psi.
Confirm. Checklist item 4 is complete.
This sign indicates the exclusion zone. Any metallic objects, even small jewelry, must be removed and stored secure.
Guideway construction coordination ensures vehicle compatibility with infrastructure systems. Close collaboration between vehicle and infrastructure.
Linear motor integration coordinates onboard magnets with guideway propulsion coils. Precise alignment and timing between
239.66. Switch mechanism design develops specialized turnouts enabling route changes while maintaining levitation.
239.67. Station design integration coordinates vehicle capabilities with passenger boarding systems.
platform screen door coordination ensures proper vehicle station interface. Synchronized door systems may...
Keep moving, quickly now. Watch your step on the slide. We need to clear the guideway immediately.
239.70. Maintenance facility design accommodates specialized servicing requirements.
Superconductor servicing capabilities enable cryogenic system maintenance and magnet replacement. Specialized facility.
239.72. Magnetic field testing.
Today marks the transition from development to operation, demonstrating the commercial viability of Maglev technology.
239.74. Performance monitoring analyzes early operational data validating design assumptions.
239.75. Reliability achievement tracks system availability and failure rates. Operational.
Energy efficiency measurement compares power consumption against conventional high-speed rail.
With a 98% satisfaction rate, we are proud to present the future of travel.
239.78.
Economic analysis evaluates operating costs and revenue potential.
Environmental impact assessment measures noise, energy use, and land disturbance. A comprehensive environmental evaluation compares
technology transfer potential, explores exporting Maglev.
Successful operations demonstrate technology maturity, creating opportunities for international deployment.
German Transrapid heritage influenced early maglev development despite limited commercial deployment. Electromagnetic suspension
Connecting the world's largest metropolitan regions, the Chuo Shinkansen Maglev line promises to transform intercity transportation.
At 239.86. Cost challenges acknowledge substantially higher infrastructure expenses than conventional rail, elevated
Weather resilience provides reliable operations unaffected by snow and ice. Elevated guideway avoids snow accumulation.
Noise. These regions produce quieter ice than conventional high-speed transport. Nicht noiseless Operationen benefits.
239.2. Gradient capability climbs steeper grades than wheel rail adhesion allows, making propulsion unaffected.
.94. Safety record demonstrates excellent performance despite limited operational experience. Inherent safety advantages from guideway.
Fascination with futuristic technology, attracting passenger interest. Innovative transportation mode appeals to travelers.
.239.97. Technical complexity requires specialized expertise, limited.
Interoperability limitations prevent sharing infrastructure with conventional railways. Dedicated
network affections result down
Strategic applications suit specific high-traffic corridors, justifying high costs. Carefully selected routes connecting major population centers. Airport connections represent ideal application, providing rapid, prestigious access, short distances, and high passenger volume.
2239.2. Intercity people for 345.
Urban metro applications explore MAG for automated transit systems, lower speed maglev technology.
239.104. Freight applications face challenges from weight limits and infrastructure costs. Passenger-optimized designs limit heavy.
Technology evolution continues advancing superconductor performance and reducing costs. Ongoing research promises.
Material science progress develops lighter, stronger composites, reducing vehicle weight. Advanced materials enable weight.
Automation enhancement improves operational efficiency through sophisticated control systems.
Answer. Cost reduction efforts focus on manufacturing efficiency and design optimization, economies of scale and design refinement.
Standardization initiatives promote interoperability, enabling larger networks and competition. International cooperation developing. Environmental benefits include zero direct emissions and reduced noise pollution, electric propulsion and quiet operation.
239.11112. Energy consumption analysis shows efficiency advantages at very high speed.
Land use efficiency minimizes right-of-way requirements through elevated construction. Elevated guideway reduces land acquisition.
Disaster resilience provides transportation during earthquakes and extreme weather. Elevated guideway and contactless operation.
Innovation, inspiration. National prestige motivates some governments pursuing maglev despite costs. Technological leadership aspirations.
Tourist attraction potential creates destinations and enhances regional profiles. Iconic maglev systems become attractions themselves.
239.118. Technology demonstration validates concepts inspiring future applications. Operational systems. Alternative Future explores Hyperloop and other advanced concepts. Maglev represents stepping stone toward even more advanced.
Global competition drives parallel development for countries. International rivalry and rivalry as
Research collaboration advances fundamental science benefiting broader applications. Maglev research contributes to superconductor science.
The electromagnetic coils create this incredible propelling force, allowing it to reach such high speeds.
It's amazing.
Engineering achievement celebrates East Asian human-led.
Future potential anticipates broader deployment as costs decline. Continued development promises eventual cost reductions.
Sustainability contribution provides zero-emission high-speed transportation option. Renewable-powered Maglev